This video is a quick review of how to graph quadratic functions, and there's a couple of methods that are available to us. For example, if the quadratic function looks like this, y equals ax squared plus bx plus c, which is sometimes we call general form, or that's how you will see it, or a vertex or a standard form, which is y equals a times x minus h squared plus k, or basically it would look like this, like the square is completed essentially. Okay, so I'll do a very quick review of the first method using the transformations, which are also called shifts, which may be familiar to you, but I will let you guys kind of just read it from it. Basically, the idea is we're starting with y equals x squared, which is a basic parabola, where the vertex is at the origin, or the lowest point. Sometimes we call it the minimum. So if a is negative, then the graph is reflected about x-axis, and if a is positive, then it's facing up, it's not reflected. And there's various things you can know. If a, what you multiply your parabola or function by, is greater than 1, well, I think about it this way. If it's 2, for example, you multiply all your y values by 2, then you're going to get a narrower graph, or taller or stretched. The idea is that the y values are going to go to infinity faster. Or vice versa, if a is less than 1, then the graph is wider or compressed. The reason for absolute values is that it doesn't matter if a is positive or negative. It could be -5, for example. Still, the idea is you're multiplying your y values by 5. Negative just means it's going to be reflected about x-axis, but it's still going to be stretched. And vice versa with compressed. So the sign doesn't matter. It's going to be just the value of a, whether it's positive or negative. And also the shifts, just a quick review. With horizontal shifts, it's a little bit less straightforward, because if h is positive, now we're talking about negative in the original equation. Sometimes I remember what makes it 0. For example, if it's x minus 2, it's positive 2 that's going to make it 0. Now it's actually moving to the right, and it's moving to the left if you have, let's say, x plus 2 in the original equation, and then it's going to move 2 units to the left. And up is more straightforward. It's up if it's plus, if you're adding a number on top of your function, and vice versa, minus, it means down. Now let's take a couple of examples, like let's say y equals x squared minus 3. Now notice there is no horizontal shift. There's basically the only thing that we have is a vertical shift. So it's x squared, but it's shifted 3 units down. And notice how the graph looks like a regular parabola, but it's starting at 0, -3. This is where the vertex would be. Actually, it would be 0, -3, because there's no horizontal shift. Let's take a look at another one. What if we have x minus 3 squared plus 2? What do you think the shifts would be? Now, let's take a look. Well, it turns out we have 3 units to the right and 2 up. The vertex, notice how it's going to be at 3, 2. And so this is where it goes. And so again, it looks like a regular parabola. What if we have negative, same graph, but it's negative in front of the x squared? Well, same idea. It's still 3 units to the right, 2 up, but it's reflected about x-axis. So it's the same graph, but it looks upside down. Now, this works with shifts, but of course, your general parabola is usually going to look like this, y equals ax squared plus bx plus c. And to put it in that vertex form, we can either do completing the square, which takes, sometimes it can get quite involved, especially if your a is not 1. So let's talk about a different method to graph. I usually like to put it in 5 steps. For example, you got to find a, b, and c first. Let's take a look. Well, if a is positive, it's the same kind of idea. Parabola opens up. If a is negative, it opens down. How do we find vertex? It all depends on quadratic formula, which is where we're getting. So x equals 2. It's part of quadratic formula, if you remember, in -b. Then there is a square root portion, and then it's divided by 2a. So it's negative b over 2a for the x. Y, basically, I'm using function notation here, but you're going to plug in negative b over 2a into the original equation. So that's what the vertex is. Axis of symmetry, every parabola has axis of symmetry. It's basically around the x of the vertex, if you notice. Y-intercept, this is where c plays a role. If x is 0, then you're going to get c, or a constant, and that's the y-intercept. X-intercept, this is where quadratic formula comes in. You set the equation equal to 0. If you can factor, do so. If it's difficult or sometimes not possible, then use quadratic formula. And there are some steps that you can use because sometimes you don't need quadratic formula. You do not always get x-intercepts. If you notice the graph above, sometimes the parabola doesn't even cross x-axis. So what happens if the discriminant, this is what we call, or this portion under the square root, what if it's positive? Then we do get 2 x-intercepts, and you may want to use quadratic formula or factoring if possible. What if it's exactly 0? Well, notice the square root part will be gone, so you're going to be left with negative b over 2a, which is exactly the vertex. So it's the vertex sitting right on the x-axis. So you don't get any new information in this case. And third case, what if it's negative under the square root? Well, then you have imaginary numbers which do not give us any x-intercepts. Again, you don't get any new information. So only in the first case you actually have to do something to find more points. And then you would graph the parabola. You can use symmetry if necessary. So I did a couple of examples. X squared plus 5x plus 6 is 1. And then I kind of go through the points. It's facing up. The vertex happened to be negative 5 over 2. Plugging it into the original function, you get negative 1/4. So this is the vertex, and axis of symmetry is x equals to negative 5/2. Y-intercept is 0, 6. X-intercept we could factor in this case, which is what I did. So you get negative 3 and negative 2. And the graph, I tried to draw it by hand. You plot all the points. You had 5 in this case. This is where the symmetric one looks like. Remember how the vertex was a fraction? I think it was negative 2.5. And I kind of estimated it to be at negative quarter down here. Notice the symmetry, if it's 2.5 units to the axis of symmetry, then it's going to be 2.5 units to the other side, which I think it's going to be at negative 5. So it kind of helps to have the symmetric parabola. Then you can have, here's another example, y equals negative 2x squared minus 12x minus 16. This one is facing down. Let's go quickly through all the information. Vertex happens to be negative 3, 2. So be careful with signs when you plug it in. Y-intercept is negative 0, negative 16. X-intercept, we set it equal to 0 again. We could factor it. Notice how I factor out negative 2. And then I noticed you can factor. And so the x's are negative 4 and negative 2. And then let's take a look at the graph. Same thing. I plotted all the points. And notice how it's facing down. And this is what it looks like. And here is a couple of quick applications, I believe. Let's say if the cost is, here is a revenue, which is quadratic, and the cost is a linear function. Let's take a quick look. Find the minimum break-even quantity. Usually maximum and minimum pertain to the vertex idea, but let's read this carefully. It's a minimum break-even quantity, so the revenue is equal to the cost. Notice how I set them equal to each other. And then you would solve. I basically put everything on the same side, set it equal to 0. If the x squared of the coefficient is negative, you can factor it out, which makes it easier to factor. So notice I get 2 zeros in this case, x equals 5 and x equals 1. But recall, we were asked for the minimum number of batches that needed to be sold to break even. Well, it's 1. So if you look at the graph, we were actually being asked for the first x-intercept as opposed to the vertex. So the vertex usually pertains to the y value, maximum or minimum. And break-even was the x value. Then the question keeps going. Maximum value, now this is a vertex question because it's a quadratic function and it's facing down, if you recall. So I basically found the vertex. Then we had to plug in into the actual revenue equation. and I get 16,000 was given in the original problem. It was in thousands of dollars, so it's 16,000. And maximum profit, same idea. I actually found the profit equation, revenue minus cost. It's a quadratic equation which should look familiar with break-even. So maximum, once again, is the vertex, which I found and plug in back into the equation, and I got 4,000. And that's it.